VU meters are all the rage at the moment. Why? For gain staging. That's why. It's simple. Insert a VU meter into every track, adjust your track gain or clip gain so the VU meter bounces up to around 0. You're done. Gain staging. Start mixing. Well, that's the short story. There's a longer story to be told, and the story really can be as long as you want it to be. An epic, a saga, King Alfred, the fall of princes, Paradise Lost. The haiku, however, is don't do that. It's ridiculous. But let's look at VU meters anyway, and I really will tackle gain staging long form in a future series. Maybe just not on YouTube, but I'll tell you more about that when I can. Anyway, the VU meter. Let's have a look at one. This is a real-world bricks-and-mortar VU meter from Crookwood. It's fully standards compliant and works how VU should, which is a lot more than the majority of meters that merely look like VU meters in the physical world. So we might look at the behaviour of VU meters as defined in ANSI C16.5-1942, British Standard BS 6840 and IEC 60268-17, with roots going back to the beginnings of VU around the early 1940s. Or I might just summarise. Betty?
The reading of the volume indicator shall be 0 VU when it is connected to an AC voltage equal to 1.228 volts RMS across a 600 ohm resistance, equal to plus 4 dBu, at 1000 cycles per second. The rise time, defined as the time it takes for the needle to reach 99% of the distance to 0 VU when the VU meter is submitted to a signal that steps from 0 to a level that reads 0 VU, is 300 milliseconds. The overshoot must be within 1 to 1.5%. The fall time is the same as the rise time, 300 milliseconds. The level specification is meant at 1000 Hz. The reading should not depart from the reading at 1000 Hz by more than 0.2 dB from 35 Hz to 10 kHz, or more than 0.5 dB between 25 Hz and 16 kHz.
OK, that's all very well. But what can a VU meter do for us? Well, a VU meter can give us a reasonable indication of signal level. This was important in the old days of analog tape recording and the old days of broadcasting. Too much level in analog tape recording and you get distortion. Too much level in broadcasting and you get your station closed down. Too little level in analog tape recording and you get noise. Too little level in radio broadcasting and listeners tune to another station. Too little level in television doesn't happen. No, that never happens, particularly in commercials. The limitation of the VU meter is that it's slow, and you have to judge the level according to what kind of sound source you're metering. A sound source with a consistent level will meter accurately. An impulsive sound source, like a drum kit, will measure very low. But that's the olden days. It isn't what we use a VU meter for now. Let me sidestep to sample peak meters as we use in the digital audio workstation. In digital audio, it's vital not to go over 0 dBFS in a WAV file, either when recording or bouncing. Inside the door, it hardly matters, but going in and coming out are the potential pain points. So, we absolutely need to know the sample peak values. A VU meter would be useless for this. Absolutely useless, not just virtually useless. But what a VU meter can do that a sample peak meter can't is give you a visual indication of the loudness of a signal. The subjective loudness. It really is good at that. So, let's look at a VU meter that you might use today. I've chosen the Klanghelm VU-MT because if I wanted to use a VU, I'd probably choose this one. Alternatively, I might choose the TB Pro Audio MV Meter 2 because it's good and it's free. Or the Waves VU meter because it's simple and effective. There are others, some that I wouldn't choose because they're different to what I expect a VU meter to be. Others because I simply haven't tried them, or I might not even know they exist. I'd say if you fancy a go at VU, try a free one first, then do your research and get one that suits your purpose better. Let's dive in and see what the Klanghelm VU-MT can do. For now, I'll leave it on its default settings. Step 1. What happens when I feed this meter a sine wave at -18 dBFS? Hey, I get 0 VU. Now, this is a thing. I don't know where this is written down as a standard, and I do know that some written down standards are different, but there seems to be a consensus that minus 18 dBFS in the DAW should equate to 0 VU on the VU meter. Now, if you know where this standard is actually written down, let me know in the comments, because the internet doesn't seem to know. Well, at least the internet according to Google. But 0 VU is minus 18 dBFS. It is on all 3 VU meters that I've mentioned, using their default settings. Here's that sine wave again at minus 18 dBFS. Step 2. I said that the VU meter is slow. It takes around 300 milliseconds to reach full scale, which is nearly a third of a second, which is the kind of difference why Max Verstappen is 2 times world champion and Sergio Perez is not. With drums and other impulsive inputs, 300 milliseconds is plenty of time for a signal to blow over the top and cause clipping. But with 0 being as low as minus 18, this isn't likely to happen. Check your sample peak meter to be sure. Here's the sine again. The VU meter reads it accurately. 0 VU equals minus 18 dBFS. Here's a vocal.
Said again.
The VU underreads by 6 dB. Here's a guitar. The VU underreads by 12 dB. And some drums. The VU underreads by 16 dB. So now we know where we stand with underreading, and we can learn how to cope. And I'm forgiving the odd half a dB here and there. So the theory is that a VU meter will show us the subjective loudness of a signal. Well, don't expect miracles, but what it can do is a useful link between sight and sound. And although our ears should always be the ultimate reference point, what you see can be very useful reinforcement. Let's try it. I'm going to use the same clips at the same levels, all normalized to around 0 VU. But this time, I'd like you to pay attention to the subjective level, how loud they seem, regardless of any meter readings, either VU or sample peak.
If you hold me while the pieces set again.
I'm going to add an extra clip, which again I've normalized to peak around 0 VU. Oh, and if you don't hear anything, it's because the copyright owner doesn't think my educational example is fair use. So I'll have to mute it, which is something that YouTube allows me to do retrospectively. If so, then sorry. I don't think the subjective level matching is bad. Clearly the clips don't all sound exactly the same level, but they're not too far out. The music clip is exactly as it came down from my streaming service. If it isn't muted, then there's info on how to find the whole song in the description. Okay, that was fun. And now for some more fun, I'm going back to my olden days when I taught audio to students in a lab full of Revox B77 tape recorders. Yes, computers had been invented, but in those days students needed a whole term to learn how to use the mouse. They could start learning professional audio with a microphone, a tiny Soundcraft mixing console, and a Revox B77 straight away. So, I'd teach them how to use the console's oscillator to align the tape recorder to the console. No, let's skip that. How do you set the recording level on a Revox B77 using its internal VU meters? As I've said, the VU meter is slow and it underreads, quite drastically on very impulsive signals, as we've seen. But the Revox has a secret weapon. The VU meters have a red LED to indicate peaks. This LED is instant, at least as instant as it needs to be, and it flicks on at +6 VU. which can't be shown by the meter needle because the scale only goes up to +3. Now, my memory fails me on this. What level on tape in nanowebers per meter is the VU aligned to? Professionally, this is important, and I'm guessing it would have been 200 for 0 VU, 200 nanowebers per meter. This is a comfortable level for analog tape. Above that, the higher you go, the more distortion you'll get. It isn't hard and fast clipping like digital, just a more and more grungy sound, which for some instruments can actually give an interesting texture. So, the LED, it's aligned to +6 VU, which is 6 decibels above 200 nanowebers per meter. This is the start of the grunge zone. But you can't afford to waste any headroom, because you want to keep the average signal level well above the noise. Tape hiss, as we used to call it. So I always found it a useful compromise to record to a level where the LED flicked on a couple of times over 2 or 3 seconds. If it was on constantly, then clearly the level was too high and the recording would be very distorted. Once every second or so, you'd probably get away with it. Not coming on at all, your problem is going to be the noise. So let's look at this in the modern digital audio workstation and go back to the Klanghelm VU meter. I'll click the spanner. The spanner. I'm looking in the LED section in the lower left. This is where you can adjust the clip light settings. The default settings, as we can see, show peaking at -6 dBFS and clipping at 0 dBFS, indicated by yellow and red on the light respectively. This is okay, but the problem is that if you regard 0 dBFS as the absolute limit, which it is when you're recording or bouncing, it only shows when things have gone wrong, and basically you're bleeped. So I'll keep the peak setting at -6 and lower the clip to -3. This isn't a lot of headroom, but hey, we're just having fun here. I'll take the guitar track and bump it up by 3 decibels. Let's see what we get. Oh dear, we now see the red light, which indicates a clip. Well, what I've specified as a clip which is anything over -3 dBFS. There's still a 3 dB margin below 0 dBFS. Of course, the DAW has massive headroom internally, and this would only be an issue on recording or bouncing, or possibly an issue with plugins. Anyway, this has been a bit of fun with the VU meter. It's an interesting time telescope back to the old days and a different perspective to the sample peak meters we normally use in the DAW. There's plenty more I could say about using VU meters in the DAW. Let me know in the comments what you'd like to see. See you soon.